Unit 7, test review. I've already kind of done some work, so I will take less time during the video. So let's get going. It says write the 6 trigonometric ratios. So it's assumed you know SOHCAHTOA by now, and it's assumed you know that the reciprocal of sine is cosecant. You know that the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. If you know that, this stuff is a lot easier. You have to know that. So, obviously, we have to know what our hypotenuse is, and if you know your families, it's a 7, 24, 25 family. If you don't know that, you'd have to go a squared plus b squared equals c squared. 49 plus 576 equals c squared. 625 equals c squared. Take the square root. Square root of 625 is 25. Now don't you dare think that this is a 30, 60, 90, because if that's 7, this would have to be 7 square root of 3. So I want to take away that instinct. So now that we have all our sides, they're telling us that's our reference angle. So if that's our reference angle, this is the opposite. We know this is the hypotenuse. We know this is the adjacent. I think you'd be wise to label those before you start actually filling your answers in. So what's the opposite side? It's 24. What's the hypotenuse? 25. That can't be reduced, so leave it. Flip it. 25 over 24 is your cosecant. Cosine is adjacent. That's 7 over the hypotenuse, 25. Flip it to find secant, 25 sevenths. Tangent is opposite over adjacent. Flip it, 7 over 24. We're going to do the same thing for letter B, but we got a different situation. We got a 6. You got to find this, and then use that information. Now some of you might get a little creative with your old geometry. Divide that by 2, you get 3. Divide that by 2, you get 5. And that's a 3, 4, 5 family, so I double that to get this side to be 8. Or you could go a squared plus the thing we're trying to find squared is 10 squared. That'd be 100 minus 36, which is 64. Take the square root. So one way or another, you better be able to find that this is 8. Now if this is my reference angle, that makes this my opposite side. I know this is my hypotenuse, and by process of elimination, that's my adjacent. So sine is opposite over hypotenuse, which can be reduced to 3/5. Flip it to find cosecant. Easy peasy. Cosine, adjacent over hypotenuse, which reduces to 4/5, which technically I could have used this, but flip it, 5/4. Tangent, opposite over adjacent, so that's 6/8, which reduces to 3/4. Flip it, 4/3. There's that. Number 2, what are the other trigonometric ratios of theta in a right triangle with the given value? Well, so we know that sine is 5/13. That's telling you, draw it so the opposite side is 5 and the hypotenuse is 13 in quadrant 1. Well, if my opposite is 5, remember this is my reference angle. It's sandwiched between the spinner and the x-axis. And my hypotenuse is 13. I'm just going to use families. That's a 5, 12, 13 family. Find it using Pythagorean theorem if you don't like families. And now we can find everything. So we know right away that cosecant of theta is just the reciprocal, so we don't even need the triangle for that one. But then we got to go to cosine. That'd be so here's my sides: opposite, hypotenuse, adjacent. So cosine would be my adjacent over my hypotenuse, which tells me secant is the reciprocal 13/12. Now let's go ahead and find tangent. Tangent by definition is opposite over adjacent, so that's 5/12. The reciprocal function is 12/5. There they are. This one's going to be slightly more difficult because they gave you some wacky numbers, but all right, I don't know what that little dot is. We're just going to ignore that, but they're telling us to say your reference angles in the fourth quadrant, which means not here, not here, not here. Tangent, so we take a look at that, and it's got to make us wonder. Tangent is opposite over adjacent. So which one does this negative go with? The opposite or the adjacent? Does it matter? Well, if we take a look at this in the fourth quadrant, if we draw, I'm just going to draw this in like a 45, 45, 90, even though I know it's not. But just to get started, I know that's my theta. Here's my opposite side, which has to be negative because that's down. And here's my, so that's my opposite side. This is my adjacent side, which is positive because that's just to the right. So I know my negative goes with my opposite side. Now, we're going to label stuff. So this is negative 56. My adjacent side is 33. And I'm going to go ahead and do some work. Hit pause a second. All right, so here's my work. A squared plus B squared equals H squared, or C squared, hypotenuse. Square that, add them together, and now I'm going to take the square root, and I already used the calculator, and it gives us a nice, neat 65 is our hypotenuse. Now we can find anything. So the easiest thing to do would be to find cotangent. I'm going to erase this so I have some space here. So cotangent is just the reciprocal of this. So if I wanted to just keep the negative right there randomly, flip it. Now we're going to get a little bit more specific. Sine is opposite, negative 56. Hypotenuse can never be negative, so that's 65. Flip it for cosecant. Now this is weird. The negative just stays in the numerator. So even though the hypotenuse can't be negative, it looks like it is, but we're just flipping it and keeping the negative upstairs. Cosine would be my adjacent side, 33 all over 65, and that means the reciprocal secant is 65 over 33. And there they are. Okay, a little bit of a story problem, but not much. 15-foot ladder, so my ladder's 15 feet, leaning against the side of a house, forms a 65-degree angle with the ground. So that doesn't mean up here, it means here, because this is the ground. We know this is 90, and because we're in a perfect world with trig, and it says, what's the distance from the house to the base of the ladder? So they're asking us to find this distance. Well, if this is our reference angle, that makes this the opposite side. We know this is the hypotenuse because it's the side opposite the 90. That makes this the adjacent side. So I've got this. I'm trying to find this, so I'm going to ignore the opposite side. So I think about this. So ka toa, which trig function uses the adjacent side and the hypotenuse? Cosine, adjacent and hypotenuse. So I'm going to say, all right, cosine of my reference angle is the adjacent side over my hypotenuse. Take your calculator. Now I'm going to show this again. It's very important. You just get in the habit of doing this. You got to make sure you're in degree mode because that's what we're dealing with. And we can flip those back and forth. So you got to check your calculator. And cosine of 65 degrees gives us this nice decimal, 0.42. I'll round it a little bit, 0.423 equals x over 15, multiply by 15, multiply by 15, and voila, 6.34 would be our distance there along the ground. To the nearest hundredth, I got lucky, so there you go. Okay, number 4, an airplane, there she is climbing at a 12-degree angle. This is the ground. With the ground, and flies a horizontal distance. That's just another way of saying along the ground, not this distance. That's not horizontal. 20 miles through the air as it climbs. What is the altitude of the plane? So they're asking, how high does it go? Well, if this is the reference angle, which it is, that's my opposite side. This is the adjacent. Again, SOHCAHTOA. Which trig function uses the opposite and the adjacent? Tangent. Tells me what to do. Tangent of 12 degrees is opposite over the adjacent, 20. Look this up. Tangent of 12, 0.213. 0.213 equals x over 20, multiply by 20, gone, multiply by 20. I'll use my calculator here. 4.25, approximately 4.25 miles. That's up there. Okay. Find x and y in each triangle. So you can tell 60, 90, the only thing that can be left is a 30. This is clearly the shortest side, so if we remember our rules, I don't want to confuse you right now, but this is your rules. That's x, that's 2x, that's x squared of 3. So if we know our hypotenuse is 16, that's saying that this is 16, so we could go 2x equals 16. Ooh, I shouldn't use these variables. These variables are going to be confusing. Maybe I'll explain it a little different, because it is easier than I'm showing it. If the hypotenuse is double the short side, that means the short side's half the hypotenuse. So I just take half. So that's 2. Now how do I get from my short side to my medium side, the side opposite to 60? I multiply that by the square root of 3. So this would just be 2 square root of 3. Okay. Letter B. We have another 30, 60, 90. But this time they give you the side opposite to 60. So the way I explain it is we have to multiply the short side by the square root of 3 to get this side. So to get back, we just divide by the square root of 3. So I take this and I divide by the square root of 3 to get back. Those just cancel. So that would be 5. And then I always double the short side to get the hypotenuse, so this is 10. In your 45, 45, 90 rules, you've been taught a few times, x squared root of 2. So that means you multiply this by square root of 2 to get the hypotenuse, you divide by the square root of 2 to get back. Let's see what they gave us. They said a leg, so don't forget, these are legs, and this is the hypotenuse. So, but they say the leg, one leg is 5. Well, you can pick either one of these because they're the same, but then I have to multiply that by the square root of 2 to get the hypotenuse. Now they're going to go with reference angles. It says find a positive angle and a negative angle and an angle over 360 for each reference angle. Well, so because this starts out positive, it stops right here, I would just find the positive one by going 67 degrees and then going another full circle. So I'm just going to add 360, which would give me 427 degrees for my positive one, and that checks, that's over 360, so I can put a check in that box. But I also need to find the negative. So that means I start here, I spin it that way, and I stop. But remember, this is in a negative direction because we went down, So to find that, we would go 360 minus 67, which would be 3, that'd be 293 negative degrees. There's my positive, there's my negative. One of them's over 360, so we're good to go. Number 8. So they tell us 63-degree angle, that's a reference angle of 63 degrees, so that's sandwiched between the x-axis and the spinner, which means this original spin is to be thought of as a negative 63 degrees. Now to find the other one, the other negative one, I would just keep going all the way around for another revolution, which means I add another negative 360. So that's negative 423. Now to find, because the original one was negative, to find the positive, I would just go 360 minus 63, which would be 297. So there's my positive one, there's my negative one. 25-degree reference angle in quadrant 2. So that means I spin my spinner all the way here, leaving me with this 25-degree reference angle here in the second quadrant. So that means to spin my spinner that way, I'd have to go 180 minus 25, which is 155. That's how far we spun our spinner to get there. Now it does say, and an angle over 360. So on this case, I'm going to have to go one more revolution to find that one. So that'd be 155 plus 360, because the first answer wasn't over 360. So I'm going to add this, 511, and that'd be 515 degrees. So there's my positive one. That puts a check in the box for that request. Now the negative one would just be, go here, and then all the way to there. Well, that's just 180 plus 25, which is 205, but it's negative. And the last one, so I have a 14-degree reference angle in the third quadrant. So that's sandwiched between the spinner and the x-axis. So now we can get going. So my original spin had to be 180 plus 14, which is 194. Now because that's not over 360, they want us to keep thinking about adding 360 to that. Try to do this in my head. My head for 554 degrees. But to find the negative one, we'd start there, and we'd go that far. That's just 180 minus 14, which is 166 degrees, but that's negative. So there we go. That ends part 1.